we've looked at the general context in which Aurelia works. Again, I'd invite you again to have a closer look at the documentation on Aurelia, Aurelia.io. Particularly view this video for a few moments. It's only short, it's only 5 minutes, and a quick skim through perhaps the early versions of the guides here. I'm going to take a look now at what building an Aurelia app looks like. I've demonstrated this app already. This is it here. Can we just draw your attention to it in light of the conversation we've just had? Notice I'm changing aspects of the UI here and it's being all updated dynamically. Also notice that I seem to be not running, as I said, purely client side. There seems to be a host up and running here. So we'll see what that's like in a moment. Okay, let's go into the framework itself then. First steps, we'll call it. And the code I'm showing you here is exactly what you'll be seeing in the lab. We've discussed here the general context, why we think Aurelia is good. We like the idea that it's bringing future standards in. This is a little bit different from our experience with Node, which tends to lag a little bit. Future standards appear on the beta branch, and we tend to stick pretty firmly to the stable or the releases, or we call them the LTEs. With Aurelia, because we're on the client side and because we can completely control the environment, there is more opportunity to be forward thinking and to bring in more advanced features of the JavaScript framework without paying a stability penalty. The classic way of starting an SPA is to download a CLI, a command line interface. These CLIs now are packaged as NPM modules. So you just on your own desktop enter in a single command like this, and when we do that, we're getting an Aurelia command line application available on our console. The G command here means that this isn't a component we're installing inside a given module as we've been doing it to date. We're just installing a Node package globally, and that package happens to provide a CLI for us. Once we've it installed, we get a new command available on our workstation. That command is AU. We type AU, we'll get the help on it. And to create a new application, we just type AU new and then the name of the application we want to create. Donation client is what we're going to do. Once it's created, we can immediately open it in WebStorm, and I'm showing you a screenshot there of what WebStorm will show you straight away. Now it looks a little bit overpowering when you first see it. We've got a dozen artifacts on screen here at least, and if I delve into any of the subfolders, there's a lot more activity going on there as well. Also, perhaps a little bit confusingly from our Node experience, we seem to have a Node modules folder. That might suggest that we're building a server-side app or something. Well, not quite. This is purely for development. It's introducing various components in the build cycle and can be discarded once we deploy it. In fact, the only thing we're going to be editing in the entire application development cycle is this folder. This is where our app lives, source. We touch other files very occasionally, but 99.9% of the work takes place in this folder, and we can ignore all the others largely. We will be touching this file maybe just once when we get started, because that's the single page that will be loaded by our app. That is the SPA, if you like, a single page application. But that single page application pulls in what it needs from the context of our application itself. To run the application, we're not really browsing index, at least not initially. We're issuing this command here, au run -- watch. This does a lot of work in assembling all of the artifacts we will have been building inside source, all of these, into a single application page that's loaded and rendered. We browse the application at localhost 9000, and if we make any changes in our IDE, we would expect it to be dynamically updated on screen. The important step we need to take in developing Aurelia apps is to understand that the debugger we may have been using for server side is no longer relevant, and any debugging will need to be focused on the browser. So in the lab today, we will immediately open up the developer tools in Chrome, dig into our sources, and we'll be able to see the components we're building immediately, inspect variables, and set breakpoints. Also, we'll be very interested in making sure we keep an eye on the console, because messages coming up here will be of significance, particularly if we make any mistakes or generate any errors. It can't be emphasized strongly enough that being competent and comfortable exploring and debugging in the client, that is in Chrome developer tools, is probably essential as you make progress into Aurelia. There's so much going on here that easy to make a slip up and almost impossible to uncover unless you're debugging and exploring in these developer tools windows. The source folder that we developed and we evolve inside our app is mapped precisely into the source folder inside Chrome. So that structure will be roughly maintained, not quite identically, but close enough, and you will be able to drop breakpoints and follow event flow inside Chrome. At the very start of our lab, we'll introduce a few small things into Index. Index is the single page, that is our app itself. We're just going to be including semantic and I think that's the only thing we're bringing in, so we can use the styling framework we're used to using. Once we've done that, you'll see that the body of our index page contains nothing. Well, nothing apart from this here. That is, it's loading up a single JavaScript file, and our entire application will be poured into that. That is, our entire application seems to be living in here. This is the purpose of the command line tool we've just downloaded and executed. When we say AU run, we're effectively asking the framework to assemble in scripts a compiled, compressed, minified version of the application we have designed in here. This application can be thrown away, and when we deploy, all we need is the scripts folder. Scripts folder is largely machine generated, unreadable. We just know it's there, and we know it's going to be generated by our command line tool. Let's look at a simple example. Here is a form. It's a fairly standard semantic form. We've got the semantic classes you'll see here, UI form. We're using field. We're using a submit button. So all of that is giving us the behavior we're used to seeing in a semantic styled page over here. We have a button, and it's a numeric field. What happens now when we start to explore some particular parts of this form as defined by these features here: submit trigger and value bind. These are new. These are not aspects of semantic. These are aspects of Aurelia. Submit trigger and amount are bound to a JavaScript object. the JavaScript object they're bound to must have a field called amount and must have a method called makeDonation. We don't really care what else it has. We maybe don't care what it's called. We just want an object that gives us these two features. And if it does, we're bound to them. And once we're bound to them, well, that makes a lot of interesting things possible. Here's an example class that will do the job for us. It's a JavaScript class. It's got a field called amount, which is a number, and we've got the makeAmount method we desire. Put those two together and we've got data binding delivering us a component. We might call it donate.html and donate.js. No other code needed, and once we have both of those perhaps in the same folder, as you'll see shortly, then once they are displayed, they're bound together. When the button is pressed, this method will be called, and this value will be updated. Here's how we would put it into our project. Creating a folder called View Models. This folder is here. And then that folder contains the HTML template we've just looked at and the JavaScript component we've just looked at. Up at a slightly higher level, we have app.html, which is the starter page for our application, and app.js. This is the main, if you like, or entry point into our application. And I'm showing those both here. This is app.html. It's a template itself, and it composes a view model that we've defined as donate. And this is our application class itself. Think of it as main. It's going to be instantiated when our application launches, and we can start to enhance that later on with interesting features. Also up at the higher level is environment and main. Environment is here. It's just defining our general context, whether we're in debug or testing or not. And then the main class itself is here. This one is going to be triggered when our application is launched. It sets up some standard configuration, which we won't really be touching. And it'll finally trigger our application here with the Aurelia.start. You can see we're using promises here in the client side, and this is a callback, arrow function style, which is kicking off our application. The router we've spoken about and how we might manage routes will be something we'll be looking at later on, and we'll be intervening in this configure a little bit to enhance it slightly, but in general we'll leave it as it is, more or less. Now in the lab as well, once we've created our first little component and experimented with it, we'll see that the source for the application is immediately visible inside Chrome, and we can set breakpoints. So if I press this button here and I've set a breakpoint, it'll pause. I'll be able to see values, the current values of the various components over in the call stack and in the local variables area. You can see I can easily get at amount here, for instance, and we can run on with the application using the standard buttons here, the step over, step into, etc. So this is quite profound, really, this range of power we have here. I'm only writing 3 or 4 lines, but I've established simple direct binding between visual components and JavaScript code. Here's some more additions that you'll do in the lab. We want to enhance the panel to contain not just a number but some radio buttons. You'll notice we're introducing a number of new fields here. The first one is the JavaScript array to hold a strings. That's our payment method. We're then introducing a variable to hold the currently selected method, Cash or PayPal. We're introducing an array to hold all the candidates we think we want to manage. And then we're also introducing a variable to hold the currently selected candidate. So we're saying we'll select Lisa initially. Down here, you'll see in the log, we've just changed it slightly. So we're now logging not only the amount, but the candidate and the payment method. No other code in here, you'll notice. No event handlers, no jQuery poking at the DOM, none of that kind of thing. Just a pure model, pure information. It does mean we have to enhance the template to contain controls for these two new radio buttons and associated labels. This is a new version of it which we'll incorporate. If we look at it in a little bit more detail, we're seeing that the method here, that is the payment method, is just a label bound to $method, which will be a JavaScript object that contains the method array for us. Down here we see we're binding to method and selected method, and over here you see we're doing binding to the candidate and the currently selected candidate. Also notice we seem to have a loop. That is, both the payment method and the candidates have got a repeat statement here and here. This means that we are populating the radio buttons from the arrays. The array methods in this instance, which is here, containing Cash and PayPal, and the array candidates in the second example. And candidates contains Lisa and Bart. So that's quite subtle there, really, what's happening. And it's reasonably sophisticated, but very logical data binding in action. That is, we're binding in the template to arrays of objects in the JavaScript class. The JavaScript class is called a view model, and the template is called a view. Hence we have model, view, view model, MVVM as the pattern. There you're seeing it in a little bit more detail. We've got the model bind, checked bind, and repeat for. And here you're seeing the model bind, checked bind, and repeat for bound to candidates instead of payment method. Okay, that's enough to be getting on with. That last few slides going into quite a bit of detail now, which is reasonably challenging. The application itself that you'll end up running goes a bit beyond this, so you get a chance to see how it runs. Particularly, we'll introduce another view model over here, which is dynamically updated as we make donations. And so we've got report view model as well as donate view model. App and main and environment won't have changed from our original versions. So I think the best bet now is to take a go at the lab, and this lab will take you into the details really of how to build from scratch an Aurelia application. Again, we're going to be using WebStorm heavily. The first thing you'll be doing is installing the npm install Aurelia client. We will be disabling the JSCS for this project. The reason we're doing that is because Aurelia comes with a different formatting style and configured to use linting. So we accept that linter, which is the default behavior. And from then on, we will be just bringing in each of the small aspects of the code I've been looking at step by step and exploring the basics. Should be able to get to the end of the lab with a reasonably interesting working application like the one I've just looked at, and I'm inviting you to have a go at some of these exercises here at the end. Okay, that's it. That's our first step, and we'll take further steps in the coming weeks.